Okay, hello, this is Keandra, and I'm going to be explaining how to do a free response question. And so the free response question I chose was the AP Calculus BC 2019 one. It's question one, and graphing calculator is going to be required for this question. So the first thing you're going to want to do is when you see this question, you're going to want to pick out the stuff that you know is going to be important for each of the A through D, the sub questions. So fish enter lake at a rate. So this is the rate. This is a function. They're going to give you a function, and it's entering. So this is the rate that they're entering the lake, and it's going to be ET. And you got to remember that it's represented as ET. And then fish leave the lake at a rate modeled by L, which is LT. LT equals whatever that function is. And here's one of the most important parts is your variables. So both E, T, and LT are measured in fish per hour, and T is measured in hours since midnight. So we already have a function of the rate that fish are leaving and the rate that they're entering. And we also have at midnight, T is going to equal 0. So that's good. That's good. So we're going to begin. How many fish enter the lake over the 5-hour period from midnight, T equals 0, to 5 a.m., T equals 5? Give your answer to the nearest whole number. So how many fish are entering the lake over the 5-hour period? Wouldn't it just be plugging in 5 into the function? Well, no, it's not as simple as that. So here we have worked out problems that I'm going to kind of walk you through. And so you're going to think of it like this. ET is already a rate of change. So wouldn't you taking the integral actually give you the actual number of how many fish are going to be entering in the time measured in hours? Yeah, it is. So what you're going to do is take 0 to 5. 0 to 5 because you start at midnight, and then you're going to go to 5 a.m. And you're going to take ET because you're measuring how many fish enter the lake. Not how many fish leave the lake, not the number of fish in between those hours, but how many fish enter the lake in between midnight and 5 a.m. And you're going to get this number if you plug it into your calculator. Remember, when you're plugging into your calculator, you're just going to simply put math 9, and then it's going to show up as an integral, and you just plug in the function. And in this type of problem, since they already gave you the exact function of ET, that means that you don't have to actually write out the number, which is good because you don't want to make a simple mistake as that and lose points. So as you see, it's going to be that. But you're not done yet. You need to give your answer the nearest whole number. And don't forget, it's very important to get all your points. So the nearest whole number, 153 fish enter the lake between, and you're going to want to give, sorry, it's kind of cutting out. You're going to want to give the variables as well, because it's always safe to do that to make sure you're getting all the points you can get possible. And so, yeah, that's pretty much it for the first part of the question. Now we're going to move on to B. B is asking us, what is the average number of fish that leave the lake per hour over the 5-hour period from midnight to 5 a.m.? Okay, and I wrote down here, you're going to want to think, are they asking us the average number, or are they asking us the average rate? And if they're not asking us the average rate, you're going to want to use this formula. 1 over b minus 8 to the integral of a to b of f of x dx. Because they're asking us the average number. It's an average value, not an average rate. If it was an average rate, it would be kind of like finding the slope. It would be f of b minus f of a over b over a, but we're not finding the average rate of change. We are finding the average rate, the average number. So you're just going to plug it in. They're asking us from midnight to 5 a.m. So just like the other one, we're going to go 0 to b, but don't forget, you have to put your average constant in the front, which is 1 over b minus a, so 1 over 5 minus 0. And then you're going to do the function of LT, okay? So LT is the rate that the fish are leaving. So you're going to want to put LT. You're not going to put ET because it's not. We're not measuring how many fish, the average number of fish that enter the lake. We're measuring the average number of fish that leave the lake. So that's where we're going to take the integral, because just like the first question, the integral of LT is going to give us that number of fish. Okay, so this is it. But don't forget, they asked us. Sorry, my dogs are barking. Don't forget that you can't just leave it like that. They may give you points, but you're always going to want to make sure you go back and kind of spell it out for the reader who's going to be grading your thing. So the average number of fish that leaves that lake per hour from midnight to 5 a.m. is 6.059. And if you see, what I did there is you're going to simplify. You can't leave all this numbers, and you can, but it's just going to be easier, and you're going to make sure that you have at least up to 3 decimal places when you put your answer in. So that's important too as well. And then C is when it's going to get kind of complicated, because they gave us A and B, and it's kind of like written out for us. But C is you're going to have to really think back to second derivatives and relative max, absolute max. So C asks us what time t for 0, 0, and 8 is the greatest number of fish in the lake. Justify your answer. Okay, so greatest number of fish in the lake. Isn't that just the absolute maximum number of fish in the lake? So what do we do when we see an absolute maximum? Or kind of, what do we do when they're asking us for the absolute maximum? We do a candidates test. But it's not as simple as you think it's going to be. So we need to understand that ET, the function of ET minus LT, is the rate of change in the number of fish in the lake at the time t. Because isn't ET a rate and isn't LT a rate? And so the number of fish, the rate of fish entering minus the rate of fish leaving is going to be the rate of change in the number of fish in the lake at a certain time. And so that's the first thing we need to understand for this question. And then I just picked AT, but you can let any, it can be a BT, whatever. I let AT equal the integral of 0 to t of E of S minus LS ds. So I basically can find the rate of change in simpler terms, kind of in just a certain in a terms that I could put it in. So A of t is going to represent the change in number of fish in the lake from midnight to t hours. So basically what you're going to do is you're going to take the derivative of A of t. And when you do that, it's going to be E of t minus L of t, which is up here. It basically is the same thing. But I did this extra step to kind of show you how you can connect the calculus and move forward with relative max, absolute max. And then an absolute max and absolute min, you have to include your relative max and relative min as well. So you're going to find your critical points. So finding your critical points, you're going to find basically by finding your critical points, you're finding your relative extrema, where the derivative equals 0. And so the derivative equals 0 when the time is 6.20356. And that's going to be one of the times you're going to put in the candidates test. Okay, then you're going to go down here and we're going to do our candidates test. Sorry, it's kind of focusing. Sorry about that. Okay. T equals 0 is our start time. And at our start time, there's no fish. There's not a number of fish. The rate is 0. And that's just it, period. And then you're going to put in your T, because that's one of your critical points. And then you're going to put your endpoint, 8, which is the time at 8 a.m. when they've stopped in the problem, when they want you to stop. And to find this number, you're just going to plug it into that equation up there and get that number. And the same for this one too as well. You're just going to plug it into that equation up here and get the number. And because that is the highest number, therefore it's going to be the greatest number of fish in the lake therefore the greatest number of fish in the lake is going to be at time 6.204. And make sure you have the third decimal place to get that point and make sure that you're correct. And then finally, I know we're going over time here. D asks you, is the rate of change in the number of fish in the lake increasing or decreasing at 5 a.m.? So think of it this way. We are seeing the rate of change when the number of fish is is it decreasing or increasing at 5 a.m.? And so we're going to go back to here where, remember when I told you that you have to understand that E of T is the rate of change in the number of fish. So you're going to use that, but you have to make sure to see if it's decreasing or increasing. You're going to have to take the derivative of ET minus LT. Sorry, this is a S, but it's supposed to be T. And this is just, remember what I told you, that this is just, you're going to take a derivative of this, basically, because you're trying to see if the second derivative is going to be positive or negative. So you take this derivative, which is going to be you're going to take the derivative of this, which is going to be the second derivative of A of T, and you're going to plug in 5, and you're going to get negative 10.7228, and that number is less than 0. So of course, if you go back, therefore the rate of change, which is ET minus LT, is decreasing at time equals 5, because your second derivative, when you put in your time, it's less than 0. And if it's less than 0, that means it's negative. And if it's negative, therefore that the function or the rate of change is decreasing. And so, yeah, that's pretty much it. We're going to go over the points you can get from doing all of this. And you have to remember, you are here to get as much as points as you can. So, for example, if you don't know an answer or if you're struggling, as long as you put something down, you can get a point. And you have to remember that you can't just skip stuff when you don't know. You write as much stuff as you do know down so you can get the maximum amount of points you can in that question without really knowing it if you don't know it. So yeah, for the first question you get 2 points, and the second question you get 2 points. And these are simple questions that I'm sure Miss Hartfield or whoever your calculus teacher has basically told you they are not common sense, but they're already written in the prompt. So you're gonna have to manipulate and use what you have in the prompt, and you can easily get 4 points just off of that. And then C and D are not quite as clear as A and B are, but you still are able to kind of manipulate the question and have a deeper understanding of what's going on. Like, for example, even setting ET minus LT to 0, that can give you 1 point. If you just understand that and write that down, that can give you another point. So you just have to kind of use context clues, use your deeper understanding of calculus and what your calculus teacher has told you, and kind of learn from that. So yeah, C is going to be one of the bigger questions in the bigger, you're going to get more points from C than for example, D, because there's a more deeper understanding. As you can see, I showed you this way, but this way is still the same as the other way. This way for me is easier, but if this way for you is easier, then you can pause it and you can go over how they did that. So yeah, I hope everyone's having a great day, and good luck on your future exams or your finals or whatever. Thank you.